I'm gonna give Milo a tardy. Take that. Take that. We
I
love
didn't know
Milo.
what time the bell rings for like early out days, like end of lunch. I had no idea. I started like walking up when I saw a lot of people.
Oh man.
I saw a lot of people walking up, so I'm like, oh, maybe I'll start walking up.
Let's do this in reverse order today because I want to make sure we get through this. Then I'll answer questions from last night.
Man, that's a lot of space.
Yeah, I know. My bad. I was procrastinate. Did I give you him? Okay. Wait, am I recording? Recording. Okay, we are recording. So now that we've mastered these tests, let's start using them to compare. Everyone's here. We will now begin. So we're going to be looking at how we can compare these, and this will help us navigate ones that aren't as straightforward as ones that we've been looking at previously. Okay, I'm going to try to save some time today since we're on a short schedule. We could do the exploration, but I'm going to ask you just believe me. So with this, we're going to be starting with the direct comparison test. And what this lets us do is if we can show that there's some kind of inequality between it, if I can show one is greater than the other and I know what one does, then I can say it like converges or diverges. Like always, our theorems are very tightly written, very neatly written, very efficiently written, such that it's really hard to read them. So let's try to make sense of these things. So what I like to say is that I always look at it as A sub n is the I think of A sub n as this series I know something about. And B sub n is what I'm investigating. So for me, this is strictly how I think about it. If you guys like this, you can think about it this way. Otherwise, we have some verbal words down here that help as well. So if I know A sub n diverges, then I need B sub n to be greater than or less than A sub n. I want B sub n to be less than A sub n. Because if B sub n is greater than A sub n, it could this is converge, not diverge. Because if B sub n were greater than A sub n, it could go up forever or converge. Like, I just don't know. So that's why if A sub n is converging, I need B sub n to be less than. So if I know that A sub n diverges, then do I want B sub n to be above A sub n or below A sub n? I want it to be above. And we're going to do this using inequalities. But this is like how I kind of like to kind of visualize it, because it's really hard to keep track, like, A sub n is greater than B sub n. B sub n is greater than A sub n. So I just think of it as like, okay, well, I know this one converges, so I need this one to be less than it. I know this one diverges, so I need this one to be greater than. So I use these kind of like little visual cues. I mean, it's not math, it's just cues that help me think about it. So I'm going to show it to you this way. If this makes absolutely no sense, we will throw it away. Okay, so let's do some comparison. So when we're looking at 7 over the cubed root of n, we're looking at 7 over the cubed root of n. What is a series that we could compare it to? What does it look very similar to? We could compare it to 1 over n to the 1/3. Because the thing that's throwing me off is that 7. And what do we know about n to the 1/3? Does that diverge or converge? This one diverges. So we have our p series when p is less than 1, diverge. P greater than 1, converge. So if I know this diverges, what do I need to show about this inequality? So this is my a sub n. So I need to show that b sub n is greater than. So is 7 over the cubed root of n greater than 1 over the cubed root of n? Yes. Therefore, the sum of 7 over the cubed root n diverges by the direct comparison test. So that's what the direct comparison test is all about. If I can say this one diverges and the other one's greater than it, then it must also diverge. If I can say this one converges and the other one's lesser than it, then it must also converge. So we're using ones we know about. I know which ones diverge, I know which ones converge, and so if it diverges, I just got to show that the one I'm looking at is greater than. If it converges, I just got to show that the one that I'm looking at is less than. So that's what we're always trying to do.
So the ones where it's like, so the thing they give us is B sub n, right? Technically.
Yeah, I'm going to call this B sub n, and this is my A sub n. And I'm going to be consistent about that.
So our A sub n's are like equations we have on FAFSA, or just like
Ones you are going to get very familiar with.
okay.
So we're always, because we know about 1 over n to the 1/3. That's like from our P series. So we know about this. We know this one converges from our P series test. So by saying that this one's greater than, we can also say that they both diverge. So we're using other tests to prove that, by comparing things, saying greater than or less than, we can use what the other test does and make an assumption about this test. Not only easier, but like falls within our theorems. Like our theorem stated that we had to have 1 over this for this to be true. So now we can make this statement with 7 over it by comparing it to 1 over. So if we did this one, what could we compare this letter B to? What does it look very close to? It looks very close to a geometric. What geometric does it look close to? Does it look very close to that one?
Yeah.
Yeah, it just has that little 1 plus on it. And what do we know about the one we're going to compare it to? When r is less than 1, converges. So what do we need to show about ours? If A sub n converges, we need to show that we are, that we're less than. Okay, so it's, but it's plus 1 in the denominator. So it is less than. So we're going to say 2 sub n over 1 plus 3 to the n is less than 2/3 to the n for n greater than 1. And since 2/3 of the n converges because r is less than 1, to the n over 1 plus 3 to the n also converges. I'm picking 2/3 in because it looks like right here, it looks like 2/3. And they're both raised to the n. So that's why I'm looking at that one. When we're looking at these polynomial functions, we want to compare it to what the total degree of the function is. So I would compare this to 1 over n squared. Why is the total degree 1 over n squared? Because I have an n over n cubed, that is 1 over n squared. And what do we know about 1 over n squared? It converges. So we know our p-series converge. 2 is greater than 1. So we are looking for, if this, so we know this converges, so what do we need ours to do? We need to be less than. Is this my little, like, visual technique helping us?
Yeah.
Okay. So we need it to be less than, so we'll say n minus 1 over n cubed plus 3 is less than 1 over n squared. We have to prove it, because sometimes it's not. So we could list some terms and show that it is. We could cross multiply and show that it is. So I could say n squared. So we could say n cubed minus n squared is less than n cubed plus 3. Is negative n squared less than 3? Yes, for all n. For all n. So as soon as you get to some kind of statement that looks like logically true, we can stop. You can't, I mean, technically you could say it right here, but now you're kind of rolling the dice.
Yeah.
Cross multiplied. If you, so when you're ready to prove it, you're like, I think I need to prove this one, because if you're on the fence, you can't just look at it and see, because you can make any statement you want. You could say, this is less than that. Let's hope you're right, and if you're going to move forward with this test. But if you want to prove it, then you can do a little bit of algebra to the side and go, okay, now I can say this is true. So it's kind of like side work to prove it. You don't have to prove it. I'm not saying you have to do this. I'm doing this to feel confident. No, but sometimes it isn't true.
So what happens if it's not true?
Then you have it.
Sweet.
Yeah.
Do you ever have to go to like every test?
No, we're gonna get to a place where we're like, oh, it's one of these two tests. So we'll limit our selections. The one I always try to use is my limit comparison test, because I can always go, limit is this, done. So that one I always do, but limit 0. Limit is 0. So as soon as limit equals 0, I'm like, this is going to be here we go. Pull up my bootstraps. Let's get to work. So, but I do run the limit test every time in my head real quick. That's the one I do every time. Because like you're gonna get better at that too. Like, how do I know that's 0? Because if I look at the coefficients of highest degree, I have 0 n cubes over 2 n cubes. So I know it's 0. 0 over 2 is 0. So I look at it and go, degree, or I can just say degree of the denominator is bigger than degree of the numerator. The limit is 0. Because if I plug in infinity, I'll have a bigger infinity on the bottom. This infinity grows faster. So the limit's 0. Okay. So now we can say, that our A sub n, we are saying this is true for all n greater than 1. So B sub n converges since A sub n converges. We work on that B sub n, so we can say B sub n converges since A sub n converges. Okay, so if on this one we compared it to 1 over n squared, what should we compare this one to? It's not going to be 4 because the degrees are different. If they were both 3, I would say 4 diverges limit test, nth term test. But they're not. So what's the limit of this? 0. The degree in the denominator is bigger. So that's a bigger infinity on the denominator. So the limit test doesn't work. What is, when we did this, when we said we're going to compare it to 1 over n squared, so what should we compare this one to? 1 over, Gabe, I think I hear you. 1 over n. We're just looking at the powers, just looking at degrees. Degree 2 over degree 3 is going to be degree 1. Yeah, we don't care about the coefficients. And that, I can see how that's confusing that, because you were looking at, it's just 1 over 1, and then you said n squared. So we can compare it to 1 over n. This isn't any equivalency or anything. We're just going to compare things. It's not that. We're going to say we're using this comparison because the one thing I do know is 1 over n. I know what it does. And I can't compare it to 4 over n. I can't compare it to 4 plus 1 over n plus 1. I can't compare it to any of that. I can only compare it to 1 over n, or 1 over n squared, or 1 over n cubed, or 1 over n. Those are the only ones I can compare it to. I'm going to choose 1 over n because my degrees kind of cancel out, and this one's very close to 1 over n. It's like cousins. Closer cousins than 1 over n squared. And then I'm going to, by the comparison test, all I got to do is say, well, since this one diverges, since that one diverges, I just have to show this greater than idea, and I can say the other one diverges. We know that. We're going to put that in the memory bank. 1 over n diverges. It's the harmonic series.
The exponent is the same as p.
Yeah, so this was...
Not always diverges.
Did I say diverge?
Yeah.
Diverge, yeah.
P equals 1.
Like that. And it diverges. So then when we compare them, we're trying to say, so we need B sub n. We need B sub n. Uh-oh. Come on, let's go. It's a good day. That's close. I know. I already told you about my little, like, I get happy when I use a pen all the way. The little things in life, guys. Okay, so let's show that this is greater than that. So we're going to show that 8n squared plus 1 over 2n cubed minus 1 is greater than 1 over n. So if I cross multiply, I mean, again, you can roll the dice. You can make this statement and just run with it. You don't ever have to prove it. Maybe you can do it in your head and see it and be confident in it. Maybe not. And you're like, let me just do a little bit of let me do like 1 minute of side work, 2 minutes of side work to get to a place where I feel confident. So I'll say 8n cubed plus n is greater than 2n cubed minus 1. So if I get, it's 6n cubed plus n greater than negative 1. Yes. And again, you don't have to do this. We're just getting to a place where we feel confident that this is true. Now I feel confident this is true. So I'm moving forward. So I can say this is true for all n greater than 1. So B sub n converges. Thank you. Diverges since A sub n diverges. So we're leaning on, and this what's like the silver lining of the comparison test is it's really going to force us to get our memory down for these other tests. Like I need to understand p-series, I need to understand nth term tests so I can use my comparison test. Typically, we're going to be comparing p-series, and that's why p-series gets used so much, is because you're using it in all these comparisons. So we end up using p-series to test a lot. So we're going to be comparing with p-series tests, and we'll also be comparing occasionally with ratio tests. But more often than not, it's this p-series idea because a lot of times we're looking at these crazy rational functions, and then I just compare it to its cousin. And I know stuff about its cousin. And I'm gonna get really good at p-series because I'm always going to be comparing to someone's cousin who's a p-series. So we'll get better at it because we're going to see them over and over. So now, unfortunately, this doesn't always work. So if we were to use what we were looking at and we were to say, well, if we compared this to 1/2 to 1 over to the 2n, so let's make that our, for our sake, the way we've been doing this, we're not going to list terms. We're going to call this our a sub n. This is the one we know things about. We're going to call this our b sub n, the one we're going to investigate. So we know a sub n is equal to 1/2 to the n, and we know 1/2 to the n will converge. Therefore, I need b sub n to be less than. So if I set this up, is 1 over 2 to the n minus 1 less than 1 over 2 to the n?
No, it's greater than.
It's greater than, yeah. So when it fails, it doesn't tell us anything. That's all it means. All it means is it failed. You know, it's unfortunate, right? It's like, well, I wish it was just told me the opposite. Like, oh, so it diverges then, right? But, I mean, it kind of feels like this has a strong chance of converging like that a sub n. So what we can do, is a different test. So we'll do the limit comparison test.
Okay, I gotta say,
Go.
my mind is like not understanding.
Yeah.
So, I don't know, this is just me being stupid.
You're not.
1 over 2 to the n minus 1 isn't less than 1 over 2 to the n.
Okay, let's do it. Yeah, just do the side work. Just do the side.
Because it'll end up being a greater number.
Yeah.
That one just much bigger.
Like, the bigger the number. Whew, I know fractions. Infinity is 0? Ah. I know. You guys are like, I should have just stopped at AB. But then AB would just be just the stuff because you're like missing all this. So. Okay. Yeah. Right. Okay, so let's apply the limit comparison test. So the limit comparison test, what it lets us do, if we compare this to a series that we know about and we get a value, a number that a positive number pops out, then the series does whatever the other series does. So the limit one's like really strong because I don't have to do any greater than or less than. I just say I know stuff about this. Let me like put these series on top of each other, and then let me evaluate. Really, and then since this is like always dividing, it's really multiplying by reciprocals because we end up dividing. We compare with a lot of like rational functions and stuff. So right here, this is going to be our A sub n, this will be our B sub n. So this is going to be the one given to us, the way this formula is working, and this is going to be our one that we're choosing. So this is going to be my A sub n. So what should we compare this with? Well, let's compare it with 1 over n cubed. What's up? I'm sorry about that. Do you want me to? I can switch it right here. If you want to.
It's fine, it's fine.
Okay.
Okay.
We can just switch it right here, and then we can keep it straight on our end.
Yeah.
Switch it.
Keep it the same.
Yeah.
Keep our notation the same. Okay. So here we're going to put B sub n over A sub n. B sub n. A sub n. So we're always choosing the A one. The B one's always given. Will that work? Okay. And we're always going to put our given over our chosen. Given over chosen. Given over chosen. So the limit comparison test tells me that I can now say the limit as n approaches infinity.
So would we not, like this one, because of how simple it is, would this be one where we could use that other one we just did? Because it's mononomial.
Yeah, we could have used it. I think what we would have found is that the inequality had been false.
Okay.
So when the inequality is false, you can jump here, or you can use this first. Like if you're looking at it and you're like, the inequality is going to be false for this. What do we know about 1 over n to the n cubed? Is that going to converge or diverge?
That is going to converge.
Converge. And we don't care about greater than or less than. We're just going to see what this equals, and if it equals a number, this converges.
And if it doesn't, then that one converges.
Probably. Yeah, either one could have worked. I don't know. I didn't do both. I'm just trying this one out. So I'm going to say the given over our chosen. But really what we can really do is skip to the fact that we're going to be multiplying by the reciprocal. And when we do this, we get 2n cubed over n cubed plus 1. We are getting faster at taking limits. What did I do?
You're the 4, the 2 over n3, n cubed plus 4.
Thank you.
If it's infinity over infinity, that's infinity, but not one, right?
No, this is where we have matching powers. So the limit is 2.
2 over 1.
2 over 1.
Oh, yeah.
Coefficients of highest degree. 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 Coefficient. What's the highest degree? 3?
3, yeah.
2 over 1. 2 over 1.
So,
So, this converges
if it equals a number,
because it equals a number.
if it equals infinity, right? Wait, is it if it equals like 0 that it diverges, or if it equals infinity that it diverges?
That is a fail. This test, what I really like about this test is if it equals a number, this series does whatever this series does.
And if it equals infinity, it's a fail.
If it equals infinity or 0, it fails. The test fails. Do something else.
Okay, that's it.
Wouldn't it be easier to start with this test? Yeah, big problem.
I'm starting to lean towards this one. It might be a little stronger than some of the other ones because then seems like there's less. It's easier, I think, mathematically, and there's less restrictions.
Yeah, that's less, yeah.
And then there's like less room for failure.
If it's, yeah, like this one.
It's like, oh, if it works, then they do the same thing. So what we can say is, since limit as n approaches infinity equals 2, and this is between 0 and infinity, B sub n converges because A sub n also converges by the limit comparison test. And maybe like, I don't think you need to have like perfect grammar on this. I think that they see like keywords like you're using the limit comparison test, you're saying the proper rules, you're good to go. Maybe technically, like if we wanted to be perfect grammar, we should probably put by the limit comparison test up front. But grammar's not needed. It's a math test.
Okay, I got a.
Yeah.
You wrote it down.
None of it makes 0. Well,
Yeah.
I shouldn't say that.
It's just like hard to remember, so sometimes.
Oh, it's so much.
Yeah,
Yeah.
that's like kind of my question.
It's gonna be like the flashcards
Yeah.
are kind of gonna be our lean on.
So when we,
Quizlet, make a Quizlet, share it with us.
so we have, we got B to them, right? So this is context.
Yes.
And then we get A to them. So if A to them has in as the exponent, what's the like, I don't know how to describe it. What determines if it's divergent versus convergent? Like if it's in the exponent, if it 0 is less than 1, so 0 is
Yeah, so when you have your n's in the exponent, if r to the n,
yeah.
if r is less than 1, absolute value of r is in between 0 and 1, we diverge.
Mean greater than 1 is convergent and equals 1 is divergent.
Equals 1 is doesn't exist because 1 to the n is 1. So if it equals 1, it actually converges, or if it equals 1, it actually diverges. Because if I was looking at 1 to the n, and I'm adding this over and over, 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1 just keeps going up. So that would diverge.
So, and then if it's not in the numerator and it's just a thing, it's the opposite, right? Like, then if it's just.
Yeah, it's the opposite of what this is, because if it was n to the p is a constant now.
Right, so if it was between 0 and 1, it would be.
Not n, p. Because n's changing. N's going up by 1 every time. So if the exponent, that's the thing that's similar between the two. If the exponent is between 0 and 1, this converge, right? Is that right?
I think, I thought it was the opposite.
Yeah, P is, we just did it. Other way around, right? So it is, so they are similar then. No, R is a ratio that's common between every term. So maybe every term is growing by 1/2.
Yes, 1/5 to the N.
Yeah, this is n raised to a constant value. So you would see n raised to the 5th.
Oh, E is the N.
Yeah. P is the exponent. R is, n's the only thing that's ever changing. So this diverges and this converges. So the rule's kind of similar looking. And 1 is diverge. Okay. Whew. Quizlet. We need a Quizlet. I need a Quizlet. Okay, what should we compare this one to?
1 over n to the 4th.
There's 1 over n.
Oh, never mind.
4 and 5. So we'll compare it to 1 over n. What do we know about 1 over n? 1 over n will diverge. So let's set our limit up. I'm going to jump straight to the multiplying by the reciprocal. We don't need complex fractions, right? So what is this limit going to equal? What does the limit equal?
0.
1/4. Oh,
yeah.
Coefficients of highest degree. This will be into the 5th once I multiply. That's 1/4. So we'll have. Any questions on how I'm getting 1/4? Okay. We're doing a lot of limits, right? So we're gonna get better at this. Oh, coefficients of highest degree. Coefficients of highest degree. Okay. So now we have this. What does that tell us? Is this between 0 and infinity?
Yeah.
Woohoo!
Yeah, 1/4 is R. Well, no, so 1/4 is like the, yeah, it is.
And all I'm assuming by like rewriting this in weird different ways is showing that it doesn't matter how you write it, as long as you say like a few keywords. You need to say what test you're using. You need to say make the statement about this one diverges, therefore this one diverges, and you need to use your proof, like the proof in the test. So the wording, like perfect wording, no, these sentences are like really difficult to write sometimes. Is that it? That's it. That's it. Okay, so I'll answer any questions from last night. Let me go over it. Let's move forward in a linear way. So here's our homework. I've already posted this information. All of these are doable. I almost recommend saving 13 through 20 for tomorrow, like whatever I don't know what your homework life is like. Tomorrow's a work day and I won't be here. Yeah, so you guys are just going to be like slamming heads together, like, how does this work? One thing I want to note is on this answer key, these letters are corresponding with the letters up top. So I'm using B saying I'm using the geometric series to do this. So for half of them, I gave you the letter to use. For the other half, I just told you what it did.
Oh, okay.
Okay? Because then technically we don't, don't even look at this until you absolutely need to. That's what you want to do, because that's the skill you're trying to build.
Yeah.
When do I use what test? That is the skill we're after. And, like, know all the rules of every test. So.
Wow, that is a lot of
Yeah.
I didn't even do
The
that.
last minute homework, and we're like writing it out.
Okay.
Say like it converges or like diverges because.
Yeah, by what test? Tell me the test and the reason within the test that makes it true.
Oh, I was, well, no, on last night.
Yeah.
Well, because it tells you what.
Oh, true.
box that you have to
Never
do.
mind. Yeah, don't worry about that then.
Okay, that's what I.
That makes sense.
It says like use this test, so.
There's no reason to tell me, unless you want to practice your sentence writing. 18. Let's see. So this looks like it is.
I can count to the pattern, I know it's like one over N. Like N to the fourth, that's it? Oh, yeah, look at what those do.
Two to the fourth is 16, 3 to the fourth is 81, 4 to the fourth is 65.
Oh, I like the pattern for that. I get it.
Is that good?
Yeah.
Anything else? Which one?
Oh, something from
9 2.
I don't know where all that stuff, Adam went, like, disappeared.
Oh, can you go around? Wait, I think that's the new word. Number 4?
4.
Yeah. You have to like expand it.
Oh, I just said
Oh,
find the
just
pattern.
find that.
Just find the pattern.
Okay.
And on this 10-3, I gave you some what to compare it to for half of them, and the other half I was like, gotta figure this out. Our tray's over here. Their stapler's over there. I don't have a sub yet for tomorrow, so it'll probably be someone random. Tell them we don't do anything in here. And
So 1 over N squared converges.
converge. Now my like diverge converge are getting mixed up in my head. I'm like, wait, does converge mean it goes off forever? Does diverge?
Means I need these of them to be small, right?
So I always draw it. What does converge look like?
It's this.
Looks like that. So I need it to be under it. Because if I put it over it, it could diverge.
Right.
So it doesn't tell me anything if it's greater than. Does that make sense? What I was saying? My little picture helps me.
On these first ones, do we have to worry about, like, verifying it?
No. I don't think so.
Oh, there's like the
1 is a no conclusion. Number 5.
The front page is super.
Yeah, I get it.
This is 1 over N.
Oh, you. Are you taking the exam? Yeah. I think we're gonna get
The payments are due on.
This Friday? Oh.
I'm pretty sure that's in the AP Spanish.
I imagine. Be at TJK?
Oh, I think that might be.
So others pay in the fall.
I don't think I did.
Okay.
I don't think so.
That's not true.
I forgot to put the C on it.
Oh, that's why, okay, yeah.
I know it are, but like,
Also for the test setup, wasn't it half
Yeah.
correction? I think I got an 80 first time, but that's an 85.
You have like, one more, you do the correction policy.
you can either have, like, a laser and a correlation, kind of that, kind of, yeah, example, where that's P, right, and you look at P to determine it, or you can have where the last two, where you look at N to determine this. So for two, so for this one,
So you use this idea?
no, then you
Where,
add
one
one
max
to
is
N,
actually the value
R,
of.
and one is.
Oh, we know R equals and R
So
squared.
it, convert the
So
divergence.
I can determine what's value. Exactly. So just put R zero equals this, R five is equal to this, therefore R five four is.
I think he said,
Very good.
wait, so, yeah, but this is, yeah, I'm just trying to figure out like P and R.
Yeah.
Wait, so, no, this is P, like, no, that's, greater than one diverge is greater than. So when it's like this,
When it's greater than one, it converges,
when P is greater than one, it converges.
right?
Yeah, they diverge.
Diverge. I'm seeing the picture in my head, I'm saying it wrong.
Sure,
Keep going up and
diverge.
Is this a
So
graph
you write
or is
this
this
one
a
higher
picture?
to that.
My picture for me is like when it's going down, I think of that as converging onto something, and when I see it going up, I think of it as diverging.
Okay, so when converging is going towards.
Oh,
the
that's
center,
why.
diverging is going towards infinity.
When I can't, but he's good.
Yeah,
But.
like I see, that's how I'm seeing it.
Okay.
If you don't like it, don't use it.
No,
It's from this and this line, this is R, this is just for the other one.
converging.
Converging is going to another, diverging is going to
And so then if it's converging, then we want the other value to be less than it.
Oh.
Yeah, because if I
If it's
put
going
it
down,
over,
the last of it is like converging, you do that drawing like down, right? So then it's gotta be below it. If it's diverging, it's gotta be.
because if I put my, if it's going down, I put this above it, it can go up or down.
Oh, okay.
And if I put it below it, if it goes up, it hits it.
Oh,
And then I
that
drop
makes
that
sense.
inversion. That's how I think about it. Yeah, I know, it took me a while to even come up with that.
When I cross
And this,
What
because
is it?
R is less than one, diverges.
Yeah.
Okay, that's all I need to know.
No. R less than one converges.
Yeah. Yes.
Yes. And think about this. If R is greater than one, they are two. 2 plus 4 plus 8 plus 16 plus 32. It's getting bigger and bigger and bigger. Now when you think about 1/2. 1/2 plus 1/4 plus 1/8 plus 1/16.
Smaller, it's going towards something.
So when I cross multiply, which one's going this way?
The symbol stays the same,
And
and you're multiplying up.
up, so then the end squared would go on the
Yeah.
greater than stuff. Okay. So then
It's because it's
so it's not true.
I don't think it's greater than one. This. Yeah. When it's in the, when it's in the, that. Big one, which is in the.
This diverges.
Say this.
This converges.
That's not.
So if they're opposites for this.
I don't
think
know.
Greater than one, converge.
Think because the denominator is growing so much faster. The denominators are growing super fast when my exponent is a large number. Like this. When my exponent is a fraction number, 1/2, 1/3, 1/4, that denominator is growing much smaller. Shrinking. Yeah.
So this is,
Which is true.
E is greater than one, not two.
When P is greater than 1, it diverges.
We need to write all the
So this diverges, so this.
Converges. This is converges.
Yeah, yeah.
Okay.
So when P is greater than one, it converges.
Converges. And it's the same thinking with the other one, because if you start to think about the values that actually get plugged in, if I have n to the fourth on the bottom, that's growing really fast. The denominator is growing really fast.
Yeah.
Meaning that my sum is going to add to a number. My numbers are getting smaller and smaller. Really fast. So when n gets to when p is less than 1, it diverges when my denominator is growing really small.
It's really b of n, or b
Okay, so still,
of n converges
this should be
to
greater than this.
This,
This should be greater.
this diverges. God, I can't say the words right.
Here, like,
This converges, I'm so sorry, it's my vocabulary, that's all. This converges,
Yeah.
this converges, so this needs to be what?
so this should be greater.
This is the
Okay, I can follow.
No, I'm not open.
So much going on.
Literally, keeping normal.
Yeah.
So this one diverges, converges, this one converges,
Yeah.
goes to a number. This one goes to a number. Once it goes to a number and goes to a number, this one goes to a number, therefore this one very less than. If this one was 1 over n, it would diverge, so ours would be greater than this.
yeah, oh, so it's just the 3 over 4 to the end.
Yeah.
Which is
And then
converges.
what's the, what are you going to compare, what can we compare this to?
So, less than,
Gotta ask me.
and that is.
We want to ignore coefficient.
Plus 5 is not. Oh, yeah. On the bottom, so yeah, so it's going to.
Yeah.
You should compare that.
Not 1 over.
Oh, yeah.
Okay. What is this one?
This one, is less than 1 is that.
And yours needs to be what?
And this needs to be converted. Okay, I get. Oh, yeah. Oh.
This one does what?
That
Converges, draw a little line.
the band long,
Where does our need?
band long.
That's what it is.
That looks a lot like the
Well,
one that was 3 to the end, then it's really another n. So 1 over 3.
Yeah. What do you want to compare?
Okay. No, so 1 third the n, yeah. 1 over 3 the n. Yeah, 1 third the n. Okay, that converges. Down.
Compare 1 over.
So 1 over n. That makes
Is that right?
Yeah.
Okay.
I think so.
Pretty sure, yes. That's the first one I'd see. Because the natural log's like, what are you doing, natural log?
Yeah.
You're getting crazy over there. In natural log, the thing with natural logs, it's actually a smaller number than as n increases, it goes up very slowly. So it becomes, natural log of n is less than n.
Right.
So we can use that.
1 over n diverges, right? Because n is equal to 1.
Yeah. N is, yeah, 1 is the boundary line for the diverge converge. 1 over n's harmonic, it diverges. Goes off to infinity. I don't know which word does what. Sure.
That's a good idea.
I'll just go with yes. The one thing I can tell you is the natural log of n is less than n as n increases.
Yeah. So this one diverges.
The natural log of 5 is less than 5.
How'd you get for number 3? How'd you get your ace of n to be 1/3 consistent? Do we not do like just 1/n?
If we did 1/n, it'd fail.
What if it doesn't look true? It fails?
Which one?
Number 5. Oh, there's no conclusion.
No conclusion. That means use it in the future. That means do a different test.
Yeah.
Doesn't mean stop. Doesn't mean it failed. Yay, next problem. For this, say no conclusion. So if we chose, we had 2 options. We could have chose 1/3, or 1/3 or 1/n. 1/3
This is gonna be this one 5.
converges, 1/n diverges.
So pick the one that would be
You can kind of think of it that way, but that's like tough, right? We'll make this one make sense. Like, I don't know if we look at these enough to make sense. So what you could do is you could choose one or the other. And then you once you set up your inequality, you'll go, crap, I failed. Okay, let me try the other one. Because I'm pretty sure the inequality would fail if you set it up against 1/n. Because we want 1/n, but it would be, you want it to be greater than, and 1/n is less than 1/n times 3, because that denominator is growing faster. And if you can look at, you don't have to do it like right here. When you write it, if you look at it and go, I know this is true, you can leave it. We only do the side work stuff, cross multiply. We're not 100% confident. This is,
Yeah.
This is less than this, because the denominator is growing more.
Yeah, it's growing.
So the numerator is going at the same rate. And this denominator is growing faster than that denominator.
So it's really small.
So the number's getting smaller.
And that's just made up for
Plus 5. Every time, because they'll have the same 14 every time.
Yeah.
And then adding 5 to this one every time. That's what number is always making it. Yeah.
So then, this one is that turning that
No, I'm sorry, but, yeah. And now that's true. So once it's like, that's true, it's not true.
Yeah. nature.
Right? Now what does it do?
That converges. Right? Does it not?
That one does it.
Oh, yeah, because R is greater.
R is greater. I got the word there.
Could you help me?
Yeah. Y'all need any help with that? I know you're good.
I don't understand how that's compared to natural.
I always kind of say that my denominator. And so what is my denominator kind of thing? I should just try to over it. Let's go to 1/n.
Just split up 1/n.
Yeah, that's the only thing we can only compare to like 1/. Stuff. We don't have, like, 'cause as soon as I look at 7/, something compared to 7/, something with 1/.
So this one diverges.
That
Convert.
diverges. It goes off to infinity.
Yeah, yeah.
I will check our grammar. No, it goes off to infinity.
Yeah, and that would, no, it would go plus 1. Yeah, but natural log then can grow and that's yeah.
If you cross multiply n times natural log of n, is that greater than n plus 1? Yeah, eventually. Because natural log of n will definitely be greater than, or plus that.
So for number three, has the N repeat N.
Yeah.
How important is for the N?
I did two options.
Well, I set up.
Is it 1 over n or 1 over 1 to the third? That one is gonna work for the situation.
Yeah, because.
Yeah. 1 to the end of the wall there. So that's a good one. So we can choose between one of those comparisons. And what stinks about this is that if you're doing this, you don't exactly know which one to compare it to. You like choose one and then it might fail and then choose the other one and it might. Any questions? Hey, Ryan. I don't find it mind blowing, but they think I'm a fake fan. They're concerned. Yeah. They're like perfect.
I'm not ginger.
Okay.
Five.
For a minute. Oh, it's already moving. I can't do anything now. Back in chairs. Gladly do that. It's like using it. I don't think about something. I've been saying it backwards every time. That's wrong. Supposed to be the fearless leader. No, it doesn't work. You just say you need that.
I mean, but can you register for
Oh, you know what music like?
I'm gonna write like this.
Are you logged in?
So I guess I'll sort of
You don't have to, right? If I use my email, they can't send me the code. Because the college board
Yeah.
account is blocked from the school license.
Why would they block college board?
Because anything that doesn't have anything to do with the email can't email.
I can't, it's
I even
You do?
yeah, I get your
yeah, my school is like,
Okay. I'm gonna send you to Miss Rasmussen right now.
like, look, I was checking into the first email, but I also have to check on the website. Last one I was, yeah.
Let me see if she'll see you right now.
This is right. Did you get that? Yeah.
Hi. We're trying to get Andre into the exam, and there's like this issue with College Board, and he can't like set up his new login because our school email blocks College Board emails. Mhm. Okay. Or we have to somehow allow College Board to emails to come through on our end. Okay, got it. So, will he just need the code? Okay. And then he has to call? Okay, we'll get it done. Thank you. Bye. Woo! Let's go. Okay, you're gonna have to call College Board.
Oh,
Sweet.
I can't wait.
Man, some straight adult status stuff going on here. You'll need this code.